Stacey, what's coming up next?
Coming up next, we've got Glenn Colbert. If I've said his name right, I'm so sorry, Glenn, if I didn't. Who's going to be talking about Azure Digital Twins. And we live in a world of IoT these days. I can't remember the last time I bought a gadget which wasn't connected. And with more and more devices being connected in some kind of way, it's interesting to see what you can get out of them. And Azure Digital Twins is the new kid on the block and allowing customers to create rich models of the real world inside their digital world. Sounds awesome. Glenn's going to talk to us about that today. Glenn is a co-founder and CTO of Azure in Belgium, Microsoft MVP since 2012, and currently focused on designing and building secure, scalable, cloud-based solutions. I also happen to know that Glenn really loves Lego and is possibly the reason why I've got a couple of models in my collection. So Glenn, are you there? How are you?
Good evening. I plead guilty on the Lego part. So I have to admit I've took up playing with Lego again during the entire lockdown. So yeah, I plead guilty on that one.
It's a fantastic hobby to have.
And it's perfect excuse to buy Legos for the kids, right?
Absolutely. It's all for my son. None of it's for me. It's all for him. Okay, so Glenn, take it away.
All right. Thank you. Let me... So, as already said, I'm going to guide you today through the magical world of Azure Digital Twins. Due to the time, let's go over the intro slides a bit quicker. As I said, I'm Glenn. I'm an Azure MVP, also Microsoft certified trainer. You can find me on Twitter where I tweet about IoT and Lego. And the code I will be demonstrating today, or the code that used today during the demos, are available on my GitHub account. So definitely take a look out there to see what's happening. Azure has been something quick about Azure. Azure is focusing on everything platform as a service. We have 4 Azure MVPs in total. And since this year, we have an office in Ghent, Belgium. And also our main headquarters are in Helsinki, Finland. So, but let's quickly jump into the main topic of this evening. Yes, let's talk a bit on IoT. So IoT, if you follow or seen the presentations, it's about getting those things connected, creating insights and actions upon that. But we've seen today that the focus on connecting things, connecting your assets is that focus on that area is a bit of moving away. So there's a new trend within IoT solutions and the IoT landscape emerging, where customers really are moving beyond just connecting their assets. They really want to connect their entire environments. They want to connect their offices. In some cases, people are doing quite some interesting things with getting their home office connected. So we're really starting to move from a connected assets environment to a more connected environment, and a connected environment area. And we can see that things will definitely start to move towards a more connected ecosystem where environments start to interconnect and so on. So what we're seeing is that customers and IoT solutions are starting. Customers want to model their environment first. So they want to model out their home office, want to model out their factory floor, and then take that model, take a digital copy of it, and keep that model up to date with IoT data, use that model to do some simulations on it, and some other automated processes on those models. And this is where Azure Digital Twins comes into play. So if I'm not mistaken, the service is still in preview. It should be GA anytime right now. I think it was announced at Ignite that it would go GA somewhere end of November, beginning of December. So we're anxiously waiting about that. And Azure Digital Twins is about creating the next generation of IoT solutions. So it's focusing on modeling your environment by providing you a open modeling language. But I will come back definitely more on that later. It gives you a live execution environment to basically see the model alive, keep that model alive with some live data. You can input data onto the digital twins from different IoT systems, from business systems, and you can connect output systems. You can connect to time series insights. You can output data to storage or to an analytics layer, allowing you to further process or analyze that data that has been living inside your digital twin. So for people that already, so the digital twin currently in preview is actually a second generation. For people that already played with the first version, you will see some significant changes. First of all, in scaling capabilities, also the more flexible way of ingesting data or extracting data from it, and it's, as already said, it's based more upon open standards than the first version. So let's take a peek at each of those different topics and to set the scene for the demo later on. So it all starts. Your digital twin or creating your digital twin all starts with the open modeling language. And the open modeling language, the digital twin definition language, that's a whole mouthful. It's completely aligned with already existing services onto the Azure IoT platform. It's aligned with IoT plug and play and aligned with the time series insight data model. So the digital twin definition language is based on JSON LD, and it describes your twin, or you can describe your twin via different properties. So a property is a data field, a data field that is living on the twin. It has storage, so it's basically a state of your digital twin. Then you have the telemetry. The telemetry is measurements. Those can be events from sensor readings or any other event happening inside your digital twin. The main difference with properties here is that the telemetry is not stored on the digital twin itself. It is just a series of data that is flowing through your system. The next part you can use to describe your twin is a component. And a component allows you to build, let us say, you can see that as a sort of interface. For example, if you're describing a smartphone with your open modeling language, you could define a camera as a component, and then use that camera component to model out your front camera or your back camera. And that's the way how you should see the component. And then maybe the most important thing is the relationships. And relationships allow you to define how how your digital twin is interacting with another twin. I will definitely come back to that later, because that is really a key component of digital twins. So to come back to the mobile phone example, you would have a mobile phone digital twin, and you have a front and a back camera as a component, and then you could say in the relationship that your mobile phone has a relationship with those two cameras. So that's a bit on how that works. Once you have described your digital twin, you can create a graph via those relationships and really show a visualizations of your digital twin and how that twin is working together. So once you model that out, everything basically goes through the live execution environment. So inside your live execution environment, you can create twin instances based on the models you defined. Those twins instances are connected via through relationships and form a graph of your environment. Currently, it is not possible through the Azure portal to visualize your digital twin, but Microsoft has open sourced a tool called the Azure Digital Twin Explorer, the Azure Digital Twin Explorer. And with that tool, you have the possibility to visualize basically everything what is happening within your digital twin. The live execution environment allows you to work with events or process additional data through external compute. So for people that were working with the original version of digital twins, you notice that the compute was inside the digital twin environment. So with V2, the compute has been extracted from the digital twin environment, and you can basically bring your own compute. For example, you can use functions to do some data processing or to process the events from the digital twin. So it's really more based on eventing and data processing through external compute than really doing all the internal processing on the twin itself. To communicate or to interact with the digital twin environment, you have to communicate through an API. So everything you do with the digital twin environment is done through an API. So if you want to query data, you need to call the API. If you want to create twin instances or upload a model towards the environment, you need to do that through the API. There is, of course, an SDK available that allows you to, that basically is a wrapper around that API. But in a very basic statement, the digital twin service is just a set of APIs made available for you to model out your environment. Inputting data is done through IoT Hub, or it can come from any other data sources that you would like to update your digital twin with. Again, updating data or or putting data inside digital twins is done through the API or with the SDK, and it's just a matter of taking some compute and then hooking it up, and there is data flowing inside your system. There's the whole storage and analytics. So it's basically now we have defined our twin, we have modeled it out, we have some data being ingested and some data flowing through the system. So that's an important one. And then you can output data to other sources. You can route that via event hubs, event grid, or service bus. And those routes and endpoints basically open up a whole range of new scenarios, allowing you to store your digital twin data in a data lake. You can connect it to logic apps to automate some stuff. In the previous sessions, we saw that to automate your social media, if you want to have some data from your digital twin, output it to your social media, you can use the logic apps from the previous session, and then put some data from your digital twins out there in your logic apps. You can connect digital twins with time series insights, and to have that historical view of your data. So that was a very quick walkthrough on all the capabilities of digital twins. And I think it would be best to just show you an end-to-end demo on how digital twin works, how you can create your digital twins, so you can really have a good understanding, or you have a basic understanding on how you can create those digital twins and what the use cases are. So this is the setup that I will be showing you tonight. So it is always tricky with live demos, but I'm pretty confident this thing will work out. So what we first, let's give a high-level overview here. So first of all, what we will do is we model out our digital twins. We will upload those models in Azure Digital Twin itself. And once we have our models there, we will start creating our digital twins and create our relationships, but more on that later. So once we have that model running, we have created our relationships. What we will do is I will use a set of simulated devices that are connected through IoT Hub, and through the external compute through functions, I will update the digital twin and basically update all the running instances of my digital twin. As a last one, what I will show you is how you can extract data that is flowing through digital twins. And I will show you how you can create a route that is connected to time series insights, where you will be able to see data flowing through the entire system. So what we will do is, let me open up Visual Studio, and I hope this is visible. So what, as already said, what we will do is we will start, before you can create any digital twin or any relationship inside the live environment, you need a model. Sorry for that. You need a model. In this case, for my demo, I've modeled out my my house. So in the end of the demo, you should see a visual demo of my house. So how does this twin definition language, how does this modeling language work? So this is an example of how this is constructed. So let's take let's take a quick peek on how that looks like. The first important thing that you need to specify is the ID. So the ID consists of DTMI. It has to contain a domain, a model identifier, and then a version. So this is just to give your model a certain ID. Then you give it a friendly name, and both this type and this context are fixed values for digital twins and just have to be there for the digital twin API to understand what you're doing. All remaining interface data or data to describe your twin is found within the content array. Here, to define my house, I've added two properties, one with the construction year and one with the owner name, with the owner. Both are string types. So remember, properties are fixed values. These are stored on the twin itself and remain there. And then the important thing here is the relationship. And with defining that relationship, you basically define on your model that this interface has or can have a relationship with a target, which is the again, just specifying another ID. I will in a minute show you all this ID. It has to have a target and a name. We will come back to that name later. So my house has a target or a relationships with floor. So let's open up the floor. Here again, same approach. You have to give it an ID, give it a friendly name, and then the remaining interface data is within the contents array. On my floor, I did not specify any additional values. I just said my floor has a relationship with rooms. So if you can visualize a bit what we're doing, so I have a house. My house has different floors, and on my floors there is a relationship with rooms. So let's take a look on how a room looks like. So again, here it has an ID, it has a display name. Again, I've specified two properties. As you can see here, you will probably wondering, okay, Glenn, those look like measurements to me because they're temperature and humidity. Yes, absolutely correct. But what I wanted to do in this demo is with eventing, what I will do is I will update my digital twin with data coming from IoT Hub and store that value onto the digital twin in these properties. So my room, again, has those two properties that I will update through external events and has a relationships with my sensors that I will deploy in my room. If I take a look here, if I go to the sensors, you will see here the sensors. My sensors have a firmware version and then has the two telemetry values coming in. So what I will do in the demo here is I will upload those models. I think those already uploaded. Let me take a quick look. So yes, let me first show you the Azure Digital Twin inside the Azure portal. So when you provision Azure Digital Twin, you basically get a service like that. And the most important thing for you is the host name. And the host name is where your APIs will be hosted, allowing you to interact with. So we've created our models, and to gain some time during this demo, I already pre-uploaded those models to my digital twins. What you're seeing here is the Azure Digital Twin Explorer, And as already mentioned, this is the open source tool from Microsoft. It's available on GitHub. You can just download it, build it on your local machine, and run it. Connect it with your instance, and it allows you to really have some good visualization. So as you can see here, these models are available. I've uploaded them. If I click here, those should come up. You see here, these models are here. My house model is there. My room model is there, and so on and so on. So you can see that these models are available here. So I will just run this query to show you that currently we don't have anything within our digital twin. We only have the models defined. So how do you now create your digital twin? Create your digital twins based on the models. So as already said, how you interact with the digital twin environment is through APIs or through the SDK. So what I will show you is how to interact with the SDK and how that works. So where are we in our demo? So we have our digital twin definition language, and we've uploaded them to digital twins. So now what we will do is we will create our graph within our digital twin and through the SDK. Let's jump back to Visual Studio. Let's close this one up. So let's open this one. So how you interact with digital twins through the SDK by using the azure.digitaltwins.core NuGet package. And what you can do there is create a digital twin client. And the digital twin client is just an endpoint that you need to provide. That endpoint is your digital twin instance, and you need to provide an Azure Active Directory token. With those two combined, you have a digital twin client allowing you to interact with the Azure Digital Twin. So, and here comes the way on how you can build up those digital twins. So first of all, you need to specify some metadata. So what are you creating? So what model are you using? So in our case, I am using my house, and the kind here is digital twin. That's again a fixed value that is needed for the underlying API to know what's going on. So you take that metadata and add it to a new dictionary or a new JSON object. But together with that metadata, you add the properties that you defined on your model. So if we take a quick peek on our house, remember here we have construction year and owner in our while creating an instance of our model. You can see here that we have construction year and owner. And what you then do is you use the digital twin client and you say create digital twin async. You give your digital twin a certain ID and you pass in the twin data you have created here. So in that way, what we will have in our graph, we will have a digital twin called house based on the house model with the two properties we have provided here. And basically, this is the same you can do, for example, let me show you the floors. Again, you need to specify the metadata. So let's not do that. So this is using the floor model, again, digital twin. Remember on our floor, what we had, we didn't have any properties there. We only had a relationship. So we are not specifying any other value than our metadata. Based on that, we basically create 3 different digital twins: 1 floor, 2 floors, and 3 floors. Each of those twins will represent an instance based on the floor model, but with a different ID. So now we have our house with 3 floors. And this is basically how you model out the entire structure. Here I've created a kitchen, a living room, some bedrooms, and so on. Then I've also created the sensors. In this case, we have 5 sensors and so on. But then the most important or the most interesting part starts. So we now have created digital twins based on our models. So we have our house, our different floors, our rooms, and our sensors. What we will now do is create relationships between those digital twins, allowing you to create that graph of your house, of a house, or of your environment. Again, how you do that is you create a dictionary with some metadata in there. So you need to specify a target ID. Remember, this is the target ID of the digital twin you created, and relationship name is the relationship name of the relationship you defined in your model. Remember, on our house, we had a relationship floors, allowing you to target a certain floor. And you see that coming back in the code. So our relationship name is floor, and we're targeting, in this case, floor 1. So what we're doing then is create a relationship async. We give it the digital twin ID, give the relationship a certain ID, and then pass in the value. And this is how you create the relationships between those digital twins. So let me close that up. Let's not save that and hit the run button. And let's see what comes out of this creation. So what we will do is I will call here the setup digital twin. And what it will do, it will just call the code I've just walked you through. And it will create the digital twins and create the relationships. So as said during the start of this session, this code is available on GitHub if you want to take a peek. Go ahead, take a look at it. If you want to improve, or if you notice that some things have been horribly coded, I'm very happy to accept some pull requests. So let's hit setup digital twins. It's going. Important, I need to authorize first. Let's click this. Let's close this down. And if all goes well, you should see some things being created. I see that there's some error over there. Let's take a look on what happened. Let's okay, this an expected error where I'm trying to re-upload my model again, but the models, I already prepared those. So that should be an expected error. As you can see, we have a log file here saying our house was created, our different floors, our different rooms, our different sensors have been added. Those relationships have been mapped out, and my digital twin has been signed off. So let's close this window down. And go back to our Digital Twin Explorer. If all goes well, let's take a look and hit Run Query. And as you can see here, this is now the digital model that's available in Digital Twins based on the things we've created. You will probably notice here that I've connected this sensor to both my kitchen and my living room. This is just a way of demonstrating you there is no need to have just one-on-one mappings, but you can definitely map that digital twin out as you wish. So now that we have everything available here, let's start shooting in some data inside our digital twins. And as already said, Digital Twin is a set of APIs, and how you interact with it is through those APIs or through the SDKs. Therefore, you need to hook up external compute to ingest the data inside Digital Twins. In our case, we will be using Azure Functions. So let's jump to IoT Hub, if all goes well. We have IoT Hub. What I've created is a set of devices. You noticed here that I've deliberately named the devices after the device of the idea of my digital twins, just for the ease of having a more easier setup on this demo. So how do you now extract data that is entering IoT Hub? How you ingest this into to digital twins? You can use this by leveraging the event grid capabilities of IoT Hub. In this case, I've created an event grid subscription that filters on device telemetry. So every time there is a device telemetry available on our IoT Hub, an event will be raised. Excuse me. An event will be raised, and that event will flow onto Event Grid and will be picked up by my Azure Function endpoint and will process the IoT Hub messages. So you can ingest data from IoT Hub through Digital Twins by using this event capabilities. Unfortunately, there is no direct route from IoT Hub towards Digital Twins for the moment. So, yeah, it would be nice to see that better together story here showing up, but leveraging this through Event Grid with Azure Functions is also a perfect solution. But it would be nice to have that route to Digital Twin here as a first-class citizen. But with this, works perfectly fine. So we have our Event Grid subscription here, and we have our Azure Function, and that Azure Function is just a basic setup. What it will do, it will listen on Event Grid, and then it will filter out the data. And here with, let me jump in this code. What it will do here, it will use, again, the Digital Twin client, update the Digital Twin async, passing the Twin ID. In our case, it will update the sensors. Therefore, I've used it with the same name, and it will pass the value of the measurements here. So let's hook up, or let's start the simulator. So this simulator is now starting to transmit data into IoT Hub. Remember, IoT Hub, when there's device telemetry popping up, we will process the message, and the Azure Functions will use the SDK to update the digital twin. If we go to Digital Twin and take a look at our sensors, you see here that the temperature and humidity has been updated. You can see here that we now see live data flowing through the system. So now we're using the live data to keep that twin up to date and to process data within the digital twin. Another capabilities of digital twins is, as already mentioned, let's go back to the overview so that we don't lose the overview here. So we have our simulated devices through IoT Hub with functions updating the data in digital twins. What we now want to do is we have our live execution environment being updated by our Azure Functions. So what we want to do is now hook up some external processing tool or an external compute or something else. In this demo, I've hooked up time series insights. How we will do that is by defining a route on the digital twin towards event hubs and then connect time series insight with event hubs. But let's take a peek on how that works. I'm just looking at the time, so let's go a bit quicker. So you can create an endpoint on your digital twins. So for people that are familiar with IoT Hub, it's the same principle. Here you can create an endpoint to event grid, event hub of service bus, and then give it a name. Then you can use event routes that will use the endpoint. In our case, we will here use this one. So every time a twin gets an update, so remember, we're updating the twin through functions, updating the telemetry of it. So every time that twin gets updated, event is raised onto event hubs, and a message will be available there. So, and if all goes well, that event hub should already have some data of my simulator. And if I go to time series insights, come on. If I look at time series insights, you would see here that I will see some data flowing through the system right now. So this is live data coming from my digital twins being shown in time series insights. So this is an end-to-end functionality on how you can use digital twins and how you can leverage the different capabilities of extending your digital twins with external compute, bringing your data inside digital twins, and so on. So let's jump to the conclusion. So digital twins is there to build those next generation IoT solutions, moving away from just having your assets connected. It's built around the ability to model your environment, and it's really an event-driven approach. Remember, the most important way on how to interact with the platform is through APIs or through the SDK. So at the moment, there is no real tangible things inside the Azure portal, but if you want to visualize your digital twins, you can use the Digital Twin Explorer, which is available on GitHub as open source. So with that said, I see I've ran a bit over time. Excuse me for that. If you have questions, do not hesitate to reach out or through Twitter or through any other social media channel. Thanks for attending. You can find the source code on my GitHub account. So thanks everyone for attending. Enjoy the rest of the community day. Thank you.
Thank you very much for that awesome session. That was, again, there was a whole lot of stuff that you managed to get through in that time there. Unfortunately, we don't have time for the question that we do have. But as Glenn said, if you need to get in contact with him, go via Twitter. And yeah, thank you very much for joining us this evening.
Thank you. See you.
Bye-bye.